Welcome to part 2 on the presentation on level 1 exponent rules. So let's start off by reviewing the rules we've learned already. If I had 2 to the 10th times 2 to the 5th, we learned that since we're multiplying exponents with the same base, we can add the exponents, so this equals 2 to the 15th. We also learned that if it was 2 to the 10th over 2 to the 5th, we would actually subtract the exponents. So this would be 2 to the 10 minus 5, which equals 2 to the 5th. And at the end of the last presentation, and I probably shouldn't have introduced it so fast, I introduced a new concept. What happens if I have 2 to the 10th to the 5th power? Well, let's think about what that means. When I raise something to the 5th power, that's just like saying 2 to the 10th times 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 2 to the 10th, right? All I did is I took 2 to the 10th and I multiplied by itself 5 times. That's what's 5th power. Well, we know from this rule up here that we can add these exponents because they're all the same base. So if we add 10 plus 10 plus 10 plus 10 plus 10, what do we get? Right, we get 2 to the 50th power. So essentially, what did we do here? All we did is we multiplied 10 times 5 to get 50. So that's our third exponent rule, is that when I raise an exponent to a power, and then I raise that whole expression to another power, I can multiply those two exponents. So let me give you another example. If I said 3 to the 7 and all of that to the negative 9, once again, all I do is I multiply the 7 and the negative 9, and I get 3 to the minus 63. So as you see, it works just as easily with negative numbers. So now I'm going to teach you one final exponent property. If I have, let's say I have 2 times, say 9, and I raise that whole thing to the 100th power, it turns out that this is equal to 2 to the 100th power times 9 to the 100th power. And let's make sure that that makes sense. Let's do it with a smaller example. What if it was 4 times 5 to the 3rd power? Well, that would just be equal to 4 times 5 times 4 times 5 times 4 times 5, right? Which is the same thing as 4 times 4 times 4 times 5 times 5 times 5, right? I just switched the order in which I'm multiplying, which you can do with multiplication. And well, 4 times 4 times 4, well, that's just equal to 4 to the 3rd. And 5 times 5 times 5 is equal to 5 to the 3rd. Hope that gives you a good intuition of why this property here is true. And actually, when I had first learned exponent rules, I would always forget the rules, and I would always do this proof myself or the other proofs. And a proof is just an explanation of why the rule works, just to make sure that I was doing it right. So given everything that we've learned now, let me review all of the rules again. If I have 2 to the 7th times 2 to the 3rd, well, then I can add the exponents. 2 to the 10th. If I have 2 to the 7 over 2 to the 3rd, well, here I subtract the exponents, and I get 2 to the 4th. If I have 2 to the 7th to the 3rd power, well, here I multiply the exponents. That gives you 2 to the 21. And if I had 2 times 7 to the 3rd power, well, that equals 2 to the 3rd times 7 to the 3rd. Now let's use all of these rules we've learned to actually try to do some, what I would call them, composite problems that involve you using multiple rules at the same time. And a good composite problem was that problem that I had introduced you to at the end of that last seminar. So if I said, let's say I have 3 squared times 9 to the 8th power, and all of that I'm going to raise to the negative 2 power. So what can I do here? Well, 3 and 9 are two separate bases, but 9 can actually be expressed as an exponent of 3, right? 9 is the same thing as 3 squared. So let's rewrite 9 like that. Say that's equivalent to 3 squared times 9 is the same thing as 3 squared to the 8th power, and then all of that to the negative 2 power, right? All it is, I replace 9 with 3 squared because we know 3 times 3 is 9. Well, now we can use the multiplication rule on this to simplify it. So this is equal to 3 squared times 3 to the 2 times 8, which is 16. And all of that to the negative 2. Now we can use the first rule. We have the same base, so we can add the exponents, and we're multiplying them. So that equals 3 to the 18th power, right? 2 plus 16, and all of that to the negative 2. And now we're almost done. We can once again use this multiplication rule, and we could say 3, this is equal to 3 to the 18 times negative 2. So that's 3 to the minus 36. So this problem might have seemed pretty daunting at first, but there aren't that many rules, and all you have to do is keep seeing, oh wow, that little part of the problem I can simplify it, and then you simplify it, and you'll see that you can keep using rules until you get to a much simpler answer. And actually, the level 1 problems don't even involve problems this difficult. This will be more on the exponent rules level 2. But I think at this point you're ready to try the problems. I'm kind of divided whether I want you to memorize the rules, because I think it's better to almost forget the rules and have to prove it to yourself over and over again to the point that you remember the rules. Because if you just memorize the rules later on in life, when you haven't done it for a couple of years, you might kind of forget the rules, and then you won't know how to get back to the rules. But it's up to you. I just hope you do understand why these rules work. And as long as you practice and you pay attention to the signs, you should have no problems with the level 1 exercises. Have fun.